Okay, welcome to the second Year 12 A-Level Maths session on Trig Identities. I've blown the special effects budget on the title there. Enjoy it. Right, let's look at some slightly different questions applying our rules, particularly sine squared plus cos squared is equivalent to 1. Given that cos theta equals negative 4/5 and theta is a reflex angle, so over 180, find the value of sine theta. Well, let's have a look at this. We first write, well, we know sine squared theta plus cos squared theta is equivalent to 1. Let's put this in blue actually so you can see it maybe better. So sine squared theta plus negative 4/5 squared is equivalent to 1. Sine squared theta plus 16/25 is equivalent to 1. Sine squared theta must therefore, in fact I need the equals here, I do apologise, because I'm actually putting in particular values, so it's no longer the identity, must be whatever I add to 16/25 to make 1. So that's 9/25. So sine theta is positive negative square root of 9/25, positive negative 3/5. But which one is it? Well, let's have a think. We know our sine graph pretty well, don't we? We go there, 180, 360, 1, negative 1. So now if it's positive 3/5, it would be here. If it's negative, it would be down here. I know it's a reflex angle. I know it's a reflex angle, so it's got to be over 180 and less than 360. I look across, that's got to be negative. It's got to be the negative. The important bit here is it's a reflex angle. Positive 3/5 would give me a angle between 0 and 180, but I need a reflex angle between 180 and 360, which is negative. So I know sine theta is negative 3/5. It's about understanding your graph here. Let's have a look at another example. Given that sine alpha is 3/4 and alpha is obtuse, find the exact value of cos theta. Cos alpha, sorry. We'll do the same again. Sine alpha squared plus cos alpha squared is equivalent to 1, so I'll put in my values. 3/4 squared plus cos squared alpha is equivalent to 1. 9/16 plus cos squared alpha is 1. So cos squared alpha, again I just need equals there once I start putting numbers in. 7/16. So cos alpha has got to be positive negative square root of 7/16, but we've got to decide which one it is. Let's look at our cos graph. There we go. 180, 360, 1. You just need a nice little sketch. It tells you everything you need to know. Now, we're told it's obtuse. Well, there's 90 degrees, 180, between 90 and 180. Well, we look at where the cos graph is between 90 and 180. It's less than 0. It's negative. So I look at this and I take my negative value. Cos alpha is negative root 7/16 because I know if it's obtuse, if it's between 90 and 180, the cos graph is in a negative place. Hope that's clear. Let's look at one more. Given that A equals 3 cos alpha, theta and B equals 4 sine theta, show that 16a squared plus 9b squared equals 144. Typical question you may be asked, particularly in the exercises you're going to do in the book. So first of all we say, okay, well, cos theta equals a over 3, sine theta equals b over 4. I know sine squared theta plus cos squared theta is equivalent to 1. So in this case, a over 3 all squared plus b over 4 all squared is equivalent to 1. A squared over 9 plus b squared over 16. Again, I've got to just go revert to the equal signs once I put those numbers in, because I'm putting in particular values. It's no longer an identity once I put particular values in. I need to remember that myself. Right. Well, we're going to multiply every bit by 144, which is the lowest common multiple of 9 and 16. 9 times 16 is 144. So I'm going to say, okay, multiply that by 144. You've got 144 over 9 is 16a squared plus 144 over 16 is 9b squared. And that does equal 144. Job done. Just quickly recap those. There was the first question. Found the reflex angle, remember. Using sine squared plus cos squared, we just put in the numbers. Equals 1. Square root, decide it's negative because it's reflex. Again, we're told it's obtuse, so it has to be negative. Read the question thoroughly. You could probably do this bit quite easily now, but it's about getting whether it's positive or negative. Understand your sine and cos graph well. It will really, really help. And there we've just got a bit of manipulation, a bit of rearranging, substituting, and showing the equivalency. Okay, I hope that was clear. Thank you very much.